Hi, I'm Noah, and welcome back to Arduino Basics. By now we've covered the basics of hooking your Arduino up to a breadboard and designing a very basic circuit for it. But you might be wondering exactly how we make the Arduino do what we want. And it's very easy to just say programming and get on with it. But the process of hooking your Arduino up to a computer and all that sort of thing can be quite daunting for beginners and can be confusing if you've never done it before. So let's get into it. So the first thing you'll need is the Arduino IDE, which can be downloaded from this link, which will be in the description if you're more a fan of clicking than cross-referencing and typing. There are a million and one ways to program Arduinos, but today we're going to be covering two of them: coding via the Arduino IDE and block programming using Ardublock, which is good for younger makers and those who can't / just don't want to learn C++. Also, this is not a C++ tutorial. There are much better tutorials out there on this, and if you want to learn programming from scratch, I would recommend that you check those out. However, if you already know the basics of C++ or Java and just need to jump to Arduinos, then this is the video for you. So let's get started by taking a look at the code for the flashing LED from the last video. If you're at all familiar with programming languages, you'll notice that this is sort of a weird combination of C++ and Java. And if you, like me, are mainly a Java programmer, you might be tempted to just rely on your Java skills to create large, complex programs. However, be careful. This is a little different. Java class structures do not work here at all. Classes have to be programmed as they would be in C. I learned that one the hard way with the robotic arm. Just be careful and remember that Java does not always work because this is, again, a weird combination of C++ and Java. So with that out of the way, let's go through this code line by line and see how it works. On line 1, I initialize an integer variable called timing. This variable will keep track of the flashing period as the knob is turned. It is an integer, so it'll always be a whole number, not a decimal. In order to use decimals, you have to switch from int to float. On line 3, I started a method called void setup. The compiler will always compile the code so the contents of void setup run first. You'll always want to put your initialization code in the setup method. Also of note are these brace brackets, the curly ones, which contain the code in the setup method. Line 4 is just a default comment line that's there when you start a new sketch. I just didn't remove it when I programmed this. Lines 5 and 6 are for setting pin modes. You should always set your pin modes before using the pins, and that is done using the pin mode function. The function takes two variables as inputs, the first one being the pin and the second one being the mode. The two basic pin modes are input and output, all caps. Also of note is the pin names. Digital pins are referred to as just plain old numbers, while analog pins have an A in front of them, thus being named A0, A1, A2, and so on. In line 7, I initialize the serial communications. Serial communications are how the Arduino communicates, either through the USB port or through pins 1 and 0. Running the serial.begin method tells the Arduino that we're going to be using serial communications and that it should initialize this communication line with whatever devices it'll be communicating with. The input variable for this is called the baud rate, which is the communication speed. There are many options to choose from, but it's best to stick with the standard. I recommend 9600 as it's the default and works well for most applications. Line 8 is simply the end of the setup method, and thus the end of my initialization code. And then on line 10, we're starting a new method. This time it's called void loop. No points for guessing what this one does, but if you guessed continually looping after setup, then congratulations, I guess, you're correct. The meat of the program goes here, and although you can make additional methods, setup and loop will always be your main ones. Line 11 is just another default comment. If you want to comment your code, or comment out sections for testing, which is really useful and I fully recommend it, just start that line off with a double backslash as shown here. On line 12, we are reading the input from the analog pin to get the knob position. This is done via the analog read function. with an analog pin specified as its parameter. This will return an integer value from 0 to 1023, because base 2 and stuff. And I've set timing equal to this value using an equal sign. I found that a 1023 millisecond flash interval was long enough, so I did not alter this value at any point in the program. On line 13, we are illuminating the LED by writing the digital pin to high. If you remember from the last video, high means on. This is done with a digital write function, using the pin we want to write as our first parameter and the value we want written, high in this case, as our second parameter. Line 14 is just a delay. So this just makes the Arduino wait for a specified amount of time in milliseconds. So 1000 would be 1 second. And as a parameter, I just entered the timing variable from earlier. If you recall, that's 0 to 1023. This means that the light will turn on, stay on for the right amount of time, and then we'll go to the next line. And in that line, line 15, pin 2 is set to low. And thus the LED is turned off, and it is no longer powered. In line 16, we have yet another delay, making it hold its off state for a bit. Then in line 17, we have a serial.println method. This prints to the serial, and it works the same way as it would in Java. Serial.println prints to the serial, then creates a new line. This is different to serial.print, which does not make a new line and prints everything on one line. As a parameter, we would usually just enter a string. However, this will convert numbers to text, so we can just throw the timing variable straight in, and it'll print it out perfectly. This will allow us to monitor the timing for bug fixing purposes. Finally, on line 18, our last line, the loop method ends, and void loop will then start again from the top. So there you go. That's the code. It basically just turns the LED on, then waits, then off, then waits, then on, then waits, then off, then waits, and so on and so forth. Now, let's upload this to the Arduino. Obviously, the first step is to plug the Arduino into the computer. But after that, it can get somewhat confusing for newcomers. We will need to tell the Arduino IDE where our board is. And to do that, we are going to go into the Tools section, then Port. You will see one of the ports will have an Arduino listed beside it. COM something in this case. I'm recording the voiceover before I record the screen, so I don't know what port it is. Might be COM 3, who knows. Then you'll want to go to Tools, and then Board, and check that the correct Arduino is selected. If you have an Arduino Uno, select Uno. For a Mega, select Mecha, etc. Now, you can simply click Upload, and it should run your code perfectly. If you don't configure these things right, it is not going to run. So earlier, I was talking about implementing serial communications and writing from the Arduino to the serial. Let me show you how to see that. You're going to want to click Tools at the top again, and then click Serial Monitor. This will show you everything that the Arduino is writing to the serial. And it is an excellent bug fixing tool. If you program your Arduino to read from the serial, you can actually type here and send commands to your Arduino. But that's a topic for another video. Now, if you've been sitting there over the last however many minutes, mumbling something about no programming to yourself, then have I got the solution for you. Ardublock. You can download Ardublock from the other link in the description, and follow the installation instructions that will be available to you there. You will then be able to use block programming for Arduinos. And to launch it, you're going to want to launch your Arduino IDE, then head over to the Tools menu and select Ardublock. This will open it up in a new window. So here is the same program built in Ardublock. Immediately you'll notice that there are nice fun colors and friendly shapes to make it nice and approachable to newcomers and small children. Seriously though, if you're not familiar with programming, the nice shapes and colors can really make it easier. All of these shapes interlock nicely to show you which blocks you can put where, and make sure to minimize any mistakes you could possibly make. Regular lines of code are square with little notches in them to show you that they can stack up all nice-like. These hexagon shapes are numbers, kind of long hexagons. Booleans, that's true or false variables, are pill-shaped. Sadly, they're not red and blue pills, they're just kind of lavender. And strings, that's words and stuff, are kind of shaped like pluses. Again, longified so they can work better. You can see here how there's this one big honkin' yellow boy in the middle that is almost everything contained within it. That's our program block. And all of our code can be found within it. It has two sections, setup and loop. Those represent void setup and void loop from earlier. What a coincidence! Now you might be asking yourself, but I saw in the previous bit that we had to initialize our pins and output modes and all that stuff in the setup class, and Noah, you nincompoop, you've left it all blank. And to that I say yes. Yes I have, and I've done so for a reason. In fact, Ardublock doesn't need you to do that stuff. This code works just fine. It adds it in after, so you don't have to do it yourself. I also have initialized my timing variable outside the program block. Now, I don't believe that's necessary, especially given that it is a local variable and does not even need to be existing program-wide, but it's just here to show you that you can sort of do that stuff. Now let's take a look at the main bit of the program, that loop section of the program block. This program is identical to the one shown in the text-based Arduino IDE, and all the lines have the same function. Our first block here is a disgusting salmon color, and its job is to set the timing variable equal to the value read from analog pin 0. The second block sets digital pin 2, that's our LED pin, to high, that means on. The third block is a delay block. It delays by a specified number of milliseconds, the same number that timing represents in this case, as the timing variable is clipped onto the end. Next, we're going to set our digital pin to low. That's pin 2 again. So now it's off. Then we're going to delay again and print to the serial. So basically, we're going on, wait, off, wait, and repeat. Now, to upload to your Arduino from Ardublock, you just want to configure your Arduino in the IDE, then hit upload to Arduino from within Ardublock. And that's all done the same way as it was done earlier. And that's Ardublock. There are dozens of different blocks and they all make intuitive sense. If you've never programmed before and are awkwardly avoiding Arduinos due to having to manually code things and stuff and the learning curve and all that sort of thing, then I would recommend starting here. It's a nice sort of dip your toes in the water without having to go all in at first. It certainly isn't as complex as text-based coding, and it is more limited. But for the vast majority of simple applications, it works just fine. On the other hand, if you're sitting there looking at the screen thinking about how you're too good for a kiddie language, then why are you watching this video? Also, have some respect for people who are lesser coders. Block programming is still programming. So that was the basics of Arduino programming. Again, this was not meant to be a comprehensive programming lesson, but rather an intro to those wanting to use Arduinos and the nuances specific to programming them. Thanks so much for watching. I hope you had as much fun as I did. If you want to see more Arduino stuff, maybe consider subscribing or watch another video, which should be on the end screen now. Anyways, have a great day and thanks so much for watching.